So today our plan is to learn more about the distance formula, but this time we're going to look at it without actually using graphs. So yesterday, you guys had a lot of practice finding the distance between 2 points on a graph specifically using the right triangles. Can anybody remind me what were the 3 steps we used to solve for the distance between 2 points? Go ahead, Aiden.
First step, you turn it into a triangle.
Draw a triangle. That is our first step. Anybody got the second one?
Yes.
What is it?
No.
Oh, okay. Do I have the chat set to private only? I do. So Pamela said in private chat that the next step is to find the side lengths, specifically by counting. So we're going to count the side lengths to get the 2 side length thingies for your vertical and your horizontal. And then what is the last step? Aiden, are you still raising your hand? You got to solve using a fancy thing. What's that thing? Uh-oh. What do we use to calculate the hypotenuse?
The Pythagorean theorem.
The Pythagorean theorem. Yeah, exactly. It's the Pythagorean theorem, but that's okay. Pronouncing it funny is cool too. So yeah, first step is draw a triangle. Second step, count our side lengths. Third step, solve using the Pythagorean theorem. We're going to go ahead and start with a simple example. Find the distance between the points 0, 1, and 3, 5. So we're going to first have our little graph. Then we're going to put our little points on the little graph. And then we're going to go through our different steps. Does this have the steps? Okay. So we've got our do. We're going to draw a triangle like this. Hopefully you all recognize this part. Bottom length is 1, 2, 3. Top or side lengths 1, 2, 3, 4. Yep. Why I can't I let Phoenix in? It's not letting Phoenix in. Rough, Riley. My lines only suck a little bit. So you got a 3, a 4 triangle. At this point, hopefully you guys all know that 3 and 4 side lengths give us a 5 hypotenuse, but just in case we can solve for it, we get 9 plus 16 equals c squared. 25 equals c squared. C equals 5. Dun, 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 dun. We are done. But quick question, what is the length of the horizontal leg? I'm not going to tell you which one that is. You guys should be able to tell me. Pamela got it. Anybody else? You can use everyone chat at this point, by the way. Or you can talk out loud. That's an option too. Horizontal, Dane. Yeah, okay. And Jennifer, good. So yeah, the length of the horizontal leg is 3. Here's another question. What is the difference between the x-coordinates of point 1 and point 2? So first of all, what's the x-coordinate for point 2? If we call this point 2. Yeah, it's 3. Good, Riley. And what is the x-coordinate of point 1? Right, 0. So the difference between the two is 3. Now, what is the length of the vertical leg? It's all right, Asa. No worries.
4.
It is 4, right? What is the difference between the y-coordinates of point 1 and point 2? This time I'm not going to spoil it for you.
There's 1 point in between. The difference is 1.
The difference is not in this case. So what's the y value of 0.2? Yeah, it's 5. And we're going to subtract, what's the y value of 0.1? That would be a 1. And that'll give us a difference of 4. So what do you notice about the difference between the coordinates and the lengths of the legs? Should be pretty obvious. That might actually be the question that's on the next slide. Okay. Anybody? Somebody has to notice something between this and this and this and this. I said, what do you notice about the length of the horizontal legs, or sorry, the length of the legs and the difference between the coordinates? So Pamela, that's true, but there's a simpler way to say this. Yeah, they're the same, right? So the difference between the y coordinates is the same as the length of our vertical leg. The difference between the x coordinates is the same as the length of our horizontal leg. So basically, that's going to give us an idea of how we can start to solve this without graphing. So here's a question for you. What is the horizontal distance between the points -2, 6, and 4, 9? So first of all, horizontal, are we talking x or y on a coordinate plane? The x direction or the y direction? Yeah, so we're talking x. So what's the difference between these 2 points for their x values? Good, Dane. Good, Pamela. I'm gonna make sure some other people are taking part in this one. Good, Riley. So yeah, we have 4 minus -2, which is effectively 4 plus 2, which is 6. So the horizontal distance between these two is 6. What is the vertical distance between the points -2, 6, and 4, 9? So in this case, since we chose the last one last time, this should be pretty obvious, but are we talking x or y here? Yeah, we're talking about the y coordinates here. So what's the difference between the two? Good, Aiden. Good, Riley. Good, Brennan. Pamela. Good, Dane. So yeah, this one we have 9 minus 6. That gives us 3. So what are the side lengths of a triangle that you would draw between the points -2, 6, and 4, 9? So if I did graph this and I drew out a triangle, what would the side lengths of that triangle be? Here, I'll draw a triangle without a coordinate plane and we can pretend. Pamela, that's correct. Todd, that's correct. Aiden, your first one is correct. Riley, that's correct. There you go, Aiden. So yeah, our horizontal distance between the points is 6. So our horizontal leg of the triangle is going to be 6. Our vertical distance between the points is 3. So our vertical leg is going to be 3. And this leaves us with the question, what is the distance between the points -2, 6, and 4, 9? So all we have to do is solve this triangle for C. So in this case, we'd have 6 squared plus 3 squared equals C squared. That's 36 plus 9 equals C squared. So 45 equals C squared. We take the square root. And I will trust that Pamela got that one right. And we get C equals 6.7. Sounds about right to me. Okay, so we just solved for the distance between these 2 points without ever actually making a graph. Now that's good, but this is a few too many steps. This is taking a little bit of a long time. It's kind of complicated. It involves a lot of specific questions. Let's see if we can break this down into a little bit of a smaller or simpler thing we can use. So we're going to start, or what we're going to try to do is get a general formula. So we want to be able to get a formula to solve for the distance between 2 points that are x1, y1, and x2, y2. So these are just 2 points where x and y can be anything. To do this, we have to start by solving the Pythagorean theorem for C. So I want to see really quick what algebra skills you all have. This is actually a lot easier than it looks. How would I solve this for C? It's actually only one step. Any ideas?
You find the answer.
That's true. You do find the answer. So here, I'll make it a little bit simpler. What if I have, let's say 100 equals C squared? How do I find C?
You get the root.
You take the square root.
Yep, which is 10.
Right. So if I have C squared and I want to solve for C, what do I do in order to solve this one for C? This is not a trick question. C does equal 10 here, but not in this case. So now we're looking back at the Pythagorean theorem. How would I solve it for C? How do I get rid of the squared?
Okay, I'll answer again. You root it.
You do. You square root both sides. So this time we're going to do the square root of this, square root of this. That's going to leave us with C on this side. Now, we can't just square root a squared and square root b squared, because if we do that, what we're going to get is c equals a plus b, and that is definitely not true. But we can do this. So c equals the square root of a squared plus b squared. Now, what we need to do is start putting in some actual points. And to do this, what we're going to do is we're going to use this general formula to figure out what a and b are. So let's find the side lengths of a triangle or for a triangle for two generalized points, x1, y1, and x2, y2. So again, these can be any numbers we want, but we're not going to use numbers for right now. This is a little bit complicated. It's kind of a hard thing to follow along with, but I think you guys can do it. So if I have the point x1, y1, and x2, y2, what is the difference between the horizontal or the x coordinates of the two? It's not x. These are subs, so you can't just subtract them. Here, let's do this. No, they are not 2 times bigger. That's not what that means in this case. I see why that is confusing. Let's say we had the points 3, 4, and 5, 6. What's the difference between these two x values? Correct, it is 2. But let's actually write it out. How do you solve it? Or find the difference? 5 minus 3. Right. So you take the x value from this one and you subtract the x value from this one. So let's plug it back in here. We have x2 and x1. To find the difference, we're going to do x2 minus x1. This equals our a. Right? This is what our side length is going to be. So if we plug in the numbers 3, 4 for x1, y1, and 5, 6 for x2, y2, we'd get 2 equals a. Then what would the vertical difference be? So the difference between the y coordinates. Right, so over here it'd be 6 minus 4. What would it be for the generalized ones? Oh, I'm getting a lot of blanks here. If this is how we solve the difference between the x coordinates, how do you think we solve the difference between the y coordinates? Yeah, Jennifer, good. Anybody else have an idea before I show you? Good, Pamela. This is like the one time I wish we were actually like in person for a lecture so I could make you guys say it out loud, but that's okay. So we have y2 minus y1. That's going to be our b. Now, this might not seem particularly helpful, but remember that we just solved for c in the Pythagorean theorem. We said that c equals the square root of a squared plus b squared. Well, now we can plug in things that just use generalized points. We're also, because we're looking for a distance here, whoops, whoa, sorry. So there's the actual like solved out version of them. A equals x2 minus x1, b equals y2 minus y1. So this is the actual distance formula. Now we replaced c with d, and that's just because it's the distance between 2 points, so we wanted to use a d instead of just c. It doesn't actually really make that much of a difference. If you put c here, I wouldn't really care. But the distance between 2 points is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Todd, do you have a question?
Actually, distance is speed divided by time.
It's actually speed times time. Distance equals rate times time. Is that the one you're thinking of? That is a formula for D, but this is the distance between 2 points specifically. So this formula is very, very important. I'm going to talk about how to use it in just a second, but for right now, make sure you have this written down somewhere. You will need it on your test. And it's a lot easier to use than you might think. So if you guys remember, we had the formula m equals y2 minus y1 over x2 minus x1. This is pretty much the same idea. It's just that you're using squares and square roots instead. So I'll give you all a second to write this down, and then we're going to try a couple problems with it. The first one I'll walk through, and then we'll see if you guys can do it. And we don't actually need this. Okay. Does everybody either have a picture of this or have it written down? Or do we need more time? Because you are 100% going to need this formula. Okay. All right. So we're going to use the distance formula to find the distance between the following points. We have negative 8, 4, and 0, 10, 13, negative 7, blah, blah, blah. I'm going to walk through how to do it with A. And then B and C, I want you guys to try on your own before you take off today. So remember the distance formula. I'm going to rewrite it right here. It is x2 minus x1 squared plus y2 minus y1 squared. So what we're going to do, we're going to say d equals the square root of, what is the x value of my second point?
18.
For A.
For A? Oh, okay. 0.
Yep. Minus, what is the x value of my first point?
Negative 7.99. Maybe a little higher, give or take.
I'm going to go ahead and just say negative 8. That's going to be squared. Plus, what is my y value of my second point? Yep. And what is the y value of the first point? Good, Aiden. Squared. Okay. What is 0 minus -8? Yep, it's going to be +8. So d equals the square root of, we have 8 squared plus, what's 10 minus 4? Right, 6. So we have 6 squared. 8 squared is 64 plus 6 squared is 36. Because these are all under the same square root symbol, we have to do these first. So we're going to add them together. This will give us 100. So d equals the square root of 100. D equals 10. Now, quick question for you. If I had done this backwards and had had -8 minus 0 and 4 minus 10, I would have gotten two negative numbers. Would my answer have been different?
No,
Why not?
because a negative number minus a negative number is a double negative.
Kind of true, but there's actually something else that's important here. So, like, let's say I had a -8 minus 0 instead. That would give me -8 here, but I'd have -8 squared. Is -8 squared positive or negative?
That's -64.
It's not,
Oh wait, never mind.
because it's -8 times -8. So when you square a number, it gets rid of the negatives. So the only reason I'm telling you this is because it doesn't actually matter which point you choose as point 1 and which point you choose as point 2. You can use any of them. So go ahead and try the last two. See if you can solve them using the distance formula, and then we'll be out of here. Your homework assignment for today is pretty short. It's just a simple IXL, so I'll pull that up for just a second. It's going to be IXL N4, and you only need to go to 80. But it's a pretty short one. Some of them are graphed, some of them are not. So you'll use the distance formula a little bit. But go ahead and try these ones. I need to figure out what the answers are really quick. Okay, that one's easy. Or that one I've got. Okay. Todd, you got a square root. And also double check C. That is correct for B. Good, Pamela. Actually, I can probably pause the recording for right now.